we're looking at the comprehensive problem, 1027, and I'll let you read the details of the scenario, but what we need to know are the cash flows for each one of these, which we have right here. And then we need to just step through and answer these questions. So Sarah has asked you to analyze these two projects and recommend which one to do. So we're going to assume at the outset that they are mutually exclusive. So we're going to pick one or the other. Okay, so both of these projects have the same economic life of 8 years and an average risk characteristic. So we're just talking about average risk. And the weighted average cost of capital, or the hurdle rate, or we could also say the discount rate, is 7.2%. So let's put that right in here, 7.2, and then it does that sometimes. So you want to make sure it's 7.2, right? And then over here, 7, okay, 0.2. All right, now we just want to put in our cash flows, and you want to make sure it's 7.2, not 720. Okay, now we have a cash flows for project one. With both have an initial cash outlay or investment of 200,000, so that goes in as a negative right here. So negative 200,000, and then we have 0, 0, and then 20, 30, 40, 60, 90, 100. Okay, so 0, 0, 20,000. Let me go back again. 30, 40, 60. Okay, so 30, not 330, right? 40, 60, 90, and 100. Those are the cash flows. And you can see your chart is magically filling out right here. So this is a setup where we're actually, this data is computing at different discount rates up here. So let me just slide this over. So you can see that as we put this in, it's going to give you the net present values at these different rates, and you can change these if you want, and you can find out what the net present value is really quickly at any given discount rate, which makes this graph very useful. Okay, so let's jump back and let's put in the cash flows for project 2. It's going to be a negative 2,000 again, 200,000, and then we have 90, 70, 50, 30, and the rest 10. Okay, so 90, 70,000, 50,000, 30,000, and the rest 10,000. Okay, now that completes our analysis of the net present values at a discount rate of 7.2%, and you can see obviously that project 2 has a much higher net present value. Now we need to look at the internal rates of return for each project. So we just simply take our cash flows from here and copy them and put them down here. Well, I've actually already got them. Okay, so that's fine. I've already got them. So you just put them in here, right? You just copy them. And once you look at that, you can see that the internal rate of return for project 2 is also substantially higher than project 1. So that's going to make you want to choose project 2, both from the analysis of the net present value and the analysis of the internal rates of return. Okay, let's see what else we need to do here. So now we're looking at we want to look at what a discount rate would cause both of these projects to have the same net present value. Well, the easiest thing to do is just come down and look at our graph and see where the crossover point right here is. So we could approximately see it's a little bit over 5%. We don't know exactly what it is. I actually took the time to sort of figure it out, basically trial and error. So if we come up here and put in 5.4, I believe we're going to be very close. Well, not 540, 5.4. Okay, so it's being stubborn. 5.4. Okay, so you see very, very close. They're about $37 apart. So 5.4% is close enough. That's very close. So at a discount rate of 5.4, you can see that the net present values are very, very close. Okay, so that's why we're using the 5.4. So the hint is this 5.4, a figure that they give you in Part D. So what happens if the weighted average cost of capital is greater than 5.4? What does that mean? Well, that's the crossover point. So anything greater than 5.4, project 2 is going to have a higher net present value. And we can see that. If we put in 5.3 right here, we can see very quickly that at that point, project 1 actually goes higher than project 2. So 5.3 or anything below 5.4 is back in this area here where the red, which is project 1, has a higher net present value than project 2. Okay, so now we need to look at what is the significance of a weighted average cost of 8.81. Well, the quick way to see that is if we look at our graph, we can see that project 1 is going to go negative at 8.81. So if we come over here and put in 8.81, we can see that it's just barely positive. Project 1 is just barely, you have a net present value of $33.86. If we go higher than that by just a little bit, if we go to 8.82, we can see that it goes negative. So that's the significance of the weighted average cost being greater than 8.81%. And what about greater than 14.39%? Well, we can also see that on our graph. That's where project 1 goes negative. So if we come over here, let me slide this over, and we put in 14.4, we can see 14.4, we can see that it goes negative, barely, right? And at 14.39, which is just a little bit less than that, we can see that at that point it's still barely negative. So it's going to be positive, I would assume, at 14.3. Yes, it's just a little bit positive. So right there, 14.39 is the discount rate where the net present value of project 2 goes negative. And so at a discount rate, if we had a discount rate of higher than 14.39, we wouldn't want to do project 1 or 2, right? Okay, so Part E, further market survey research indicates that both projects have a lower than average risk, hence the risk-adjusted discount rate would be 5%. So we can look at that right here if we want. And we can see now that project 1 is going to have a higher net present value at a discount rate of 5%, because obviously we're less than 5.4, so we can also put it in over here, 5 here, and 5 here, and we can see. And we can also look at our internal rates of return again, and you can see now we have a conflict because project 1 has a higher net present value than project 2, but project 2 still has a higher internal rate of return, but we're always going to go with the project that has the higher net present value. But there is a conflict. So now we want to go back and answer questions A, D, and E, assuming that the projects are independent. So if we put in, if we put in our 7.2 right here, we can see that they're going to be, and then we can also put it in over here too. Let's go back and put in 7.2 here and 7.2 here. and we're going to say, okay, A, D, and E, not that. Yeah, okay, good. And so A is, which project would you recommend? Well, at 7.2, they're both positive. So if they're independent, you're going to do, that means you don't have to choose. You can do you can do either or both. So you would do both because both projects have a positive net present value. Answer to question D is, does the selection remain unaffected? Well, the key here is you would do both of these projects as long as the net present value was positive. So you would do project 1 up to the point of the 8.81. Anything higher, you wouldn't do a project 1, and then anything higher than 14.39 over here, you would not do project 2 because it would go negative. And then E, okay, answer questions A, D, and E. Okay, so at 5%, obviously you would do both because at 5%, once again, and you can also see it here if we plug in 5 right there, you can see at 5%, they're both positive by a long ways. So the key here is if they're independent, you're going to do the projects. The analysis is if the net present value is positive. In other words, if the internal rate of return is higher than the discount rate or cost of capital. Also, just to sort of point out, these internal rates of return are exactly where they go negative, right? These numbers right here match up with what they're asking here. So you can see it. You can see where these projects are going to go negative by just looking at the internal rate of return. I'm sure most of you figured that out already, because at this interest rate right here, we're exactly at 0, and so anything over that. So, and also just let me really quickly point out, I've got a little bit of time left, what these interest rates actually are. I'm actually down here. I'm right here. It's actually, something very exact, right? So that's what it would take right there. I'm gonna get rid of it. So that's what it would take to actually have a 0 NPV. And that's why we use spreadsheets instead of trying to do this by hand, because that would take you a really long time. So let me just go back to where it was, just to point that out to you. So, okay, so I believe that takes care. So put all your answers in here, A through F, and you'll be fine. And just remember, you need to slide this bar down here. See, I'm at the bottom. You need to slide this bar over to see the full chart or graph. Okay, that takes care of your homework for chapter 10.